Welcome to Shanti-Peace for Mathematics. The objective of this video is to discuss a numerical integration. First, let us see what is the fundamental theorem of calculus. If the integration a to b f of x dx is there, where f is a continuous function, or I can say integrable function, that can be evaluated by capital F of b minus f of a, where f derivative of f, capital F, is a small fx. This is known as a fundamental theorem of calculus, and when we integrate a function f with this manner, then it is called analytical method. And geometrically, this definite integral represent the area under the curve. That means if this is the curve and this is your interval AB, then this area which is under the curve and bounded by the x is equal to a line, x is equal to b line, y equal to 0, that is x axis, and the curve y is equal to f of x. This area is represented by integration a to b f of x dx. In analytical way, it is not possible to integrate every function. For example, if I have given you a function sine x square, and if I can tell you that integrate sine x square, then it is not possible to integrate sine x square. For example, integration of e power x upon x dx. So there are certain functions which are not possible to integrate analytically. To integrate analytically means what? Means that we have to find out the area under the curve, which we have represented in this manner. So that's why the concept of a numerical integration is important to evaluate the value of such integral numerically. So there are certain rules or some certain approximation method to calculate the numerical integration. The few of them are Trapezoidal Rule, Simpson's 1/3 rule, Simpson's 3/8 rule, and Weddle's rule, which we are going to learn in this video lecture. So let us explain you a first thing, which is a trapezoidal rule. So our objective is to find the integration of a to b f of x dx. That means the area under the curve y equal to f of x from x is equal to a to x is equal to b. This is our objective, to evaluate this integral. Now, first of all, we understood what do you mean by trapezoidal and why the word trapezoidal is there. So as we know, if I have the graph of the function in this manner, and this is the interval AB, if I divide this interval AB into n such sub intervals, let's say this is x0, then next one, let's say this is x1, x2, up to so on, and the last point we have xn. So we have divided the interval AB into the partition. The partition points are x0, x1 up to xn, when x0 is a and xn is b. We have divided this whole interval into n equal parts. Now let us looking at this area, the area which we have here. And this is one of the trapezoidum. So the trapezoidum generally lie in this manner. So this is your trapezoidum. Now the question is, what will be the area of this trapezoidum? Let's say this is A, B, C, D, and this point is E. If I consider the length of this one is h, and the height is m, then the area of this trapezoidum, I can say the area of ABCD, that is our trapezoidum, is equal to the area of ABED plus area of DEC. Now what is the area of ABED? That is the area of this, which is, if I can say this is the height of this square L, then it is H into L plus area of the DEC, that is 1 by 2 hypotenuse into the base. So that is, if this is H, as this is H, this will be H. Now this quantity is M minus L, because this much BE is L, so this quantity is M minus L. So this is H by 2 M minus L, and if you simplify this quantity, this will give you H by 2 L plus M. So area of this trapezoidum will be H by 2 L plus M, where L is the distance from this point to this point. So here this is a trapezoidum, and you can see that this is your rectangle which we have here. The area of this rectangle is this height into this base, and area of this triangle, this point we know it is f of x1. So this point is f of x1. So this height is f of x1, and the total height, that means this point, is f of x0. Area of this trapezoidum is h by 2 as per this. Here instead of L we have f of x1 plus instead of M we have f of x0. So h is this distance from x1 to x0, and we have divided this interval AB into the equal parts. So that's why all of them are h. If it is x3 here, this is also h, and so on. Now in the next task, this is our trapezoidum, that means this one and then this. So this is the things you will have here. So here also you will have the same concept. The area of that one is h by 2. The total height is f of x1 plus f of x2, and so on. So as per this trapezoidal rule, or if I add all this trapezoidal from this under the area, and we will have the integration a to b f of x dx will be h by 2 f of x0 plus f of x1, that is the first trapezoidum. The second trapezoidum is f of x1 plus f of x2, and so on. If you go further, the last one will have the area is f of xn minus 1 plus f of xn, and hence if I take h common out, h by 2 is common, and this x1, f of x1 and f of x1 coming 2 times. This f of x0 and f of x1 comes only 1 time. So we can rewrite as f of x0 plus f of xn plus 2 times f of x1 plus f of x2 up to so on f of xn minus 1. So this will be the area, or I can say approximate area of this area under the curve, and this is known as a trapezoidal rule. So the formula for trapezoidal rule, if I can write down, that is integration a to b f of x dx, I may write as h by 2 y0 plus yn. The y0 is the f of x0, yn is f of xn plus 2 times y1 plus y2 up to yn minus 1. There y0, yn and y1 up to yn are the points of a function y is equal to f of x. Let us see by example. The question is, the next example, using trapezoidal rule, compute integration 0.5 to 1.3 e power x square dx. So here the value of a is 0.5, value of b is 1.3, And now we have to, for this, the first step is to divide this interval 0.5 to 1.3 into n equal intervals. So I am fixing my n is equal to 4. If you pick your n large, then it is more accurate your answer is. That means more accurately of the area under the curve is there. For your understanding or for our understanding, we fix a smaller amount of n. It is better that you can choose your value of n is large if you want your accurate answer. So n is 4. So what is your h? That is b minus a upon n. Because I want to divide this interval ab into this many equal parts. So that will gives you 1.3 minus 1.5 upon 4, which gives you 0.2. Now we have to fix your x and y. We have to find out what is the value of x. The value of x having the difference of 0.2. The first x0 value is 0.5, then 0.7. Next is 0.7 because the difference is 0.2. Then it is 0.9. Then it is 1.1. Then it is 1.3. And if using the calculator, your function y is e power x square, using the calculator, we can calculate what is the value of y at point 0.5. Then it will give you 1.2840, 1.6323, 2.2479, 3.3535, 5.4195. This is your value of y0, this is your y1, this is y2, this is y3, and this will be y4. According to the trapezoidal rule, the integration from 0.5 to 1.3 e power x square dx as per the formula is x by 2 y0 yn plus y1 plus y2 up to yn minus 1. As you know that n equal to 4 here, so this formula is become h by 2 y0 to y4 plus 2 times y1 plus y2 plus y3. So just need to substitute this value into this formula and we will have our answer. So we will have the answer is 2.117. So this is the trapezoidal rule is there. I can give you as an exercise that you can work out with the same example with n equal to 8 and find the error. I have calculated for n equal to 8. The value of the n equal to 8 is 2.085 and the previously we have the answer is 2.117. Now in this manner we can compute the any integral approximately. The question is how much error one can get when we use the trapezoidal rule. So if your f is a function which having the double derivative is continuous, that means it is second time continuously differentiable function, then the error in the trapezoidal rule you will have it as b minus a upon 12 h square into mod double derivative of f m, where f double derivative of m is the larger value of f double dash. That means whatever the maximum value of f double dash is, it is in error bound. So this much error will be possible if you use the trapezoidal rule to compute the integral. Now the next what we will do is we will understand what is the meaning of or what will be the Simpson's 1/3 rule. In the Simpson's 1/3 rule, the objective of the Simpson's 1/3 rule is to compute f of x integration f of x dx. Now let's say your curve which we have here is passing through 3 points. The first one is x0 or x1 f of x1. The second point is x2 f of x2. The third point is x3 f of x3. Let us assume that your curve is passing through these 3 points. Now in the trapezoidal rule what we have considered, we have only we started with the 2 points and then we have drawn a trapezoidum which join these 2 points. But here the concept is not plotting a trapezoidal or not plotting a straight line between these two, but instead of that we will plot parabola which passing through these 3 points. So if we consider this parabola which passes through these 3 points and we calculate what is the area under this curve, under this parabola. We know that the y equal to ax square plus bx plus c is a form of this parabola which I have drawn by the red line. Now, if I fix this is the value which we have, which is my x2, this is x1 and this one is x3. Now the area of this, if I shift my coordinates at this x0, x2 point, then I can fix this is a 0 point. So this will be as minus h and this one is as h. Because I have to divide the whole interval into n equal parts. Okay? So now if my red curve is this ax square plus bx plus c, then it will passes through these 3 points. It will passes through the 3 points are minus h f of x1, 0 f of x2 and h f of x3. And I need to calculate what is the value of a, what is the b and what is the value of c. So we have f of x1 is equal to, if it is satisfying this equation, then f of x1 is ax square minus bh plus c. Second equation f of x2 is equal to c and f of x3 we will have it is ax square plus bh plus c. So we have the value of c which is f of x2. If I add these two equations and dh will cancel out, the value of c we have, that will gives you the value of h. If you simplify this expression 3 and calculate the value of a, b and c in terms of f of x1, f of x2 and f of x3, then we can have area under this curve, because integration a to b ax square plus bx plus c is there, but a and b is we have h minus h to h, because that is the things we have minus h to h. Integration minus h to h, ax square plus bx plus c dx is there. If I integrate this one, this is ax cube 3 plus b h square x square by 2 plus cx. Limit is from minus h to h, so it is 2 times ah cube by 3 plus ch is the answer for this. Hence, I need to calculate what is the value of a and c in terms of f of x1, f of x2 and f of x3. Value of c we already have in terms of f of x2. If I add these two, then you will have the value of a, which is things in terms of c. So what is the value of if I add these two, what we will have is 2ah square plus 2c is equal to f of x1 plus f of x3. So the value of a as c is equal to f of x2, this will implies the value of a is equal to f of x1 plus f of x3 minus 2 times f of x2 divided by 2h square. And if I substitute this value here, the value of a and value of c, then finally the integration, that means this area which we are calculating, that is this, under this parabola, which is approximate area of this curve, is I can call it a, which is h by 3 f of x2 plus 4 times f of x1 plus f of x0. This I can got by substituting the value of a and value of c. Value of a is this and value of c if I substitute here, and if I simplify, then this integral a is simplified into this form, and this is actually the known as the Simpson's 1/3 rule. If you substitute this value, so in this manner Now if this curve is extended like this, then you can have another 3 points, and you have plot one parabola which passes through these 3 points. You can construct one parabola which passes through this point, and then you can calculate what is the area under that curve, and so on. You can go further for any extended curve is there. And you can substitute all this values, then the formula will become, so integration from a to b of x dx is approximately h by 3 y0 to y to n plus 4 times y1 plus y3 up to so on plus 2 times y2 plus y4 up to so on. This is known as Simpson's 1/3 rule, or I can say it is in short h by 3 y0 plus y to n plus 4 times a sum of odd numbers coordinates plus 2 times a sum of even number of coordinates. And this rule is only used when your number of division into the interval AB is an even number, where value of h is b minus a upon 2n. And runs for, so this is known as the Simpson's 1/3 rule. This rule is used when your division of the interval AB is even. Let's solve one example based on this, and we will solve the previous example which we have discussed, that integration 0 to 0.5 to 1.3 e power x square using Simpson's 1/3 rule. What I will do is I am just taking n equal to 8. So as per the previous one, I have to divide my interval, that is value of h is b minus a upon 1.3 minus 0.5 upon 8, which gives you 1.8 upon 8, which has 0.1. So I need to fix some values, some intervals into this. The y value of y is e power x square. This is 0.5, 0.6, 0.7, 0.8, 0.9, 1.01, 1.1, 1.2, 1.3. This will give you 1.840, 1.433, 1.6323, 1.8965, 1.2, 2.2479, 2.7183, 3.3535, 42207, 5.4195. This is my y0, y1, y2, y3, y4, y5, y6, y7, y8. And now to use the Simpson's 1/3 rule to calculate the value of e power x square dx, which gives you h by 2 y0 plus y m. Because I have used my n is 8, so I am changing my formula to 2m. 4 times, for the formula it is 4 times the sum of odd number of coordinates plus 2 times sum of even number of coordinates. That is h by 2, y0 is, you have here y0 plus y8, that is the last point, plus 4 times sum of odd coordinate, that is y1 plus y3, y5, y7. 2 times sum of even coordinates, that is y2 plus y4 plus y6, and that's over, because y8 is already covered here, so you should not write again. Now we substitute all this value into this expression, and you can have value of this will be 2.0749. This manner you can able to calculate numerical integration of any such way. The question is, what is the error bound? The error bound is less than the Trapezoidal rule. This is better, and the error bound is b minus a upon 180 h raised to 4 into f to the 4th derivative m, where the 4th derivative has to be continuously differentiable. This much error bound is there. Let us have one more method, and which is known as Simpson's 3 by 8 rule. The question we have did for the trapezoidal rule, we have fixed points. So the idea is fixing a 2 points on this, and then you join that 2 points and make a trapezoidal. Into the Simpson's 1/3 rule, you have fixed a 3 points, and then you plot a one parabola which passes through these 3 points, and you have calculated the area under that curve, and using that we have calculated the approximate integration. In the third method, that is called the Simpson's 1/3 rule, instead of taking 2 and 3 points, we will take 4 points. So that is taking the area under the cubic equation. So instead of here we have taken a linear equation, here it is a quadratic equation, that is y equal to ax square plus bx plus c. This type of equation that is known as a parabola. And here we are taking the cubic equation, that is y equal to ax cube plus bx square plus cx plus d. So what is the objective? Is suppose you have this is the area which you need to calculate under that curve A to B. So instead of taking this points, let's say this is the 3 points, or I can want to calculate x0 is there, x1 is here, x2 is here, and x4 is here. Suppose I have 4 points into this. So we have to calculate, or we have to find out one curve which is passing through this 4 points and which satisfy this equation ax square plus bx square plus cx plus d. So this curve is like this. Suppose it will be the curve like this. So this is a cubic curve, and if you can find out the value of a, b, c and d as we have did in the Simpson's 1/3 rule, which satisfies this, then the area of this portion which are drawn with the white figure is, the area is this, that is 3h by 8 f of x0 plus f of x3 plus 3 times f of x1 plus f of x2. This will be the formula for that, for this white line, and the whole formula of the integration using the Simpson's 1/3 rule. It is integration a to b f of x dx will be 3h by 8 y0 plus yn plus 3 times y1 plus y2 y4 plus y5 up to so on, plus 2 times y3 y6 is missing, y6 is missing, next y9 should be there, and so on. Then your h is b minus a upon 3m. So this method, or Simpson's 1/3 rule, is used when your number of coordinates it's of multiple of 3. That is, it is of 3m type. Let us solve, or let us calculate one of the example using this Simpson's 1/3 rule. Question is evaluate 4 to 5.2 ln x dx. If you want to use the Simpson's 1/3 rule, then the value of n should be multiple of 3. So I am fixing my n is 6. To calculate points of x and 6, your value of h is b minus a upon 6, which gives you 5.2 minus 4 upon 6. It will give you 0.2. So it is 4, 4.2, 4.4, 4.6, 0.8, 5 and 5.2. Using the calculator, your function y ln of x, which having the base e, is 1.3863, 1.4351, 1.4861, 1.5261, 1.5686, 1.6094, 1.6487. So this will be the value of y0, y1, y2, y3, y4, y5 and y6. Now as per the Simpson's one-third rule, that is integration for 4 to 5.6 ln x dx will be 3h by 8, and you can use the formula as we have told you that y0 plus yn. So here n is 6, so it is y0 plus y6. 3 times y1 plus y2, y1 plus y2. 3 is missing, then y4 plus y5. Here that is 2 times y3 plus y6 is already taken here, so we will not consider that one. And if you substitute this value y0, y1 into this and you can calculate using the calculator, the value of h is 0.2, which we have already have here. This will give you 1.82758. So this is the approximate error is there. And the error bound for this method is bounded by d minus a upon at into h raised to 4 f power 4m. The next method that we have, it is known as Weddle's rule. Weddle rule is used when is a multiple of n is a multiple of 6. So when n is a multiple of 6, then the Weddle rule is used, and the formula for Weddle rule is x0 to x0 plus nh, or I can say b, f of x dx is 3h by 10 y0 plus 5y1 plus 5y2 plus 6y3 plus y4 plus 5y5 plus 2y6 plus 5y7 plus y8 and so on. So this is known as a Weddle's rule. So let us recall what we did in this lecture. We have discussed the 4 rules for to calculate or to find out the approximate value of integration. The first one is trapezoidal rule. A trapezoidal rule is used having the strip of trapezoidal find separately. And then we have discussed the Simpson's one-third rule. Simpson's one-third rule is you have to use when you must divide your interval AB into the even number of equal subintervals. Simpson's 3 by 8 rule is used when you have number of subintervals should be taken as a multiple of 3, and Weddle's rule is used when a number of subintervals to be taken as multiple of 6. And generally, of all these methods, the Weddle's rule is generally more accurate than any other rule which we have discussed in this. Of course, 2 rules, Simpson's rule, one-third rule, better than the 3 by 8 rule. So that's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or question, please drop down in the comment box below. See you in next video. Till then, bye bye, sayonara.